this lecture, I would like to solve another example based on the two-hinged parabolic arches. See here, a two-hinged parabolic arch of span 50 meters and rise 5 meters. So this is span length 50 meters and rise 5 meters is subjected to a central concentrated load, that is W will be equal to 60 Newton kilonewton, which is acting exactly at the center. Means from the here it will be 25 kilometer and from this end it will be 25 meters. It has an elastic support which yields by 0.0001 mm per kilonewton. So that will be K will be elastic yield support will be denoted with K. So take E value will be equal to 200 kilonewton per mm square and I will be equal to 5 into 10 to the power of 9 mm power 4. And alpha value will be equal to 12 into 10 to the power of minus 6 per degree centigrade and average area will be equal to 10000 mm square, approximately 10,000 mm square. And assuming secant variation, calculate the horizontal thrust developed when the temperature rises by 20 degrees centigrade. First one will be considering rib shortening and second one will be neglecting rib shortening. Generally this type of problems also coming into your semester examinations. So see here, so it includes all the formula. So already we solved some of the problems based on the two-hinged parabolic arches. The formula will be H will be equal to integral of m dash y dx by ei, again integral of y square dx by ei. So whenever they are asking regarding rib shortening, so first take down rib shortening and then neglect that one. So whenever they are asking rib shortening formula and again temperature variation formula, temperature rises formula and again giving yield support formula. So remember this formula. This formula will be simplified by solving the derivation based on the yielding supports, temperature changes. Okay, but I am taking here the formula directly for solving the problem. So you please remember the formula. So for the temperature variation, that will be L alpha T, and again in the denominator part you will get this L by EEM. So this one will be the effect of rib shortening. Okay, and again plus K value is the elastic property which yield with yielding of K per unit horizontal force. This K for yielding of the supports, this L by EAM is rib shortening, and this L alpha T is the effect of temperature changes. So the horizontal thrust developed will be whenever it will be include all these things, means the formula will be this one. Okay, so first solve all the things one by one. So first go for the numerator part, that is integral of m dash y dx by dA. So first solve up to this part and again substitute L alpha T values which is given directly in the question itself, where L equal to T, alpha value will be equal to 12 into 10 to the power of minus 6, T will be equal to 20 degrees centigrade. Okay, first I will solve up to here m dash y dx by EI. So this is also same like previous problems. So if the span range is 0 to 50, we are considering 2 times of 0 to 25, like the property what I explained in the previous problems. See here m dash y dx by ei. So what is m dash here? M dash is the moment. So for finding m dash, first consider a point p x comma y. So consider section xx at a distance of x from here, and this one will be the y, and this central rise is equal to 5 meters. Okay, so what is the reaction at A and reaction at B? So already I explained so many times, your RA will be exactly 30 kilonewton and RB also 30 kilonewton. Why? Because so whatever the whenever a point load is acting on the arches, it will be distributed equally. So based on the simply supported condition, on a simply supported beam, if a point load is acting, so the load will be distributed equally, that is 60 by 2 60 by 2. Okay, so then what is your m dash? So here RA will be equal to, sorry, RA into x, moment m dash will be equal to this RA into force into distance. See here, force will be equal to 30, distance is x, so that is 30 into x. And again, what is y will be equal to, for finding intermediate value y in between the cone A to C. So for the parabolic arches, the formula will be equal to 4r by L square x into L minus x. And what about EI? For EI also the values will be given. So see here, E value will be equal to 200 kilonewton per mm square and I value will be equal to 5 into 10 to the power of 9 mm power 4. See here, the values, whatever the values we are substituting, it is in terms of meters. So whatever the overall value given the span, but here it will be in terms of mm. So please change these values into mm only. So that is 200 into 10 to the power of 6 mm, sorry, meters square. So the value will be changes kilonewton per mm square, kilonewton per meter square. We know 1 meter will be equal to 1000 meters, that is 1000 into 1000, 10 to the power of 6. So the value will be coming in bottom, so we are taking in numerator, that is 10 to the power of 6 meters square. Then what about the I value? So I value will be equal to 5 into 10 to the power of 9. So the value is in terms of power 4. So meter will be equal to 10,000 meters. So for 4 times, how much you will get? That is 1 meter will be equal to 10 to the power of 3 mm. So if you want in terms of power 4, so it will be 12 times you will get, and that too to the denominator. So if please simplify this one, you will get 12 meter power 4. So what I am telling means, if you want mm, you can take 1 meter by 10 to the power of 3. If you want meters, but what we are doing, so mm power cube will be there. So if you want in terms of meter, you will take 1 by 10 to the power of 3. So mm power 4 times means 1 by 10 to the power of 3 into 4, which is 12 in meters. So the same value I am taking here. So if you want aside means I am taking 10 to the power of minus 12 meters. So I am taking here like that only. So which is m power 4. I value will be equal to 5 into 10 to the power of 9 into 10 to the power of minus 12 meter power 4. Here also area value will be given in terms of mm square. You can take down like that only, 10000. So mm square will be equal to into 10 to the power of minus 6 meters square. So all these values will be converted into the meters. Then substitute whatever the values you want here. So here 2 times of 0 to 25, m dash value will be 30 into x, y will be 4r by L square x into L minus x dx by EI value. So first solve this value, later you can substitute the value. So first take this value also outside, that is 2 by EI integral of 0 to 25 120 r by L square and again x square into L minus x dx. So simplify the value by your own and see whatever the value you will get. 240 r by, sorry, You have the values of r and what is the value of r? Rise will be given in the question 5 and length will be given 50. So 240 into 5 by L square will be 50 square into EI value. Take down directly here and simplify that one also. Then 0 to 25 x square L minus x cube dx. And again simplify this one. How much you will get? Check this one. 240 into 5 by 50 square. What is the E value and I value? So already we taken here, that is 200 into 10 to the power of 6, 5 into 10 to the power of 9 minus 10 to the power of 12. So overall how much you will get here? 5 into 10 to the power of minus 3. Okay. So take down all these values here. 200 into 10 to the power of 6 into 5 into 10 to the power of minus 3. And again apply the integration here. Integral of x square dx, that is where L value will be equal to 50. 50 x square will be equal to x cube by 3, again minus, for x power 3 will be equal to x power 4 by 4. So 0 to 25. So apply upper limit and then lower limit. First simplify this entire value. How much you will get? Check that one. So if you simplify this value by using your calculators, you will get around 4.8 into 10 to the power of minus 7. And again 50 by 3, apply upper limit, that is 25 whole cube minus 25 to the power of 4 by 4. So simplify again this value and then multiply with this value. So this value will be equal to 4.8 into 10 to the power of minus 7 and again 260,416.667. So what about this value? So simplify that one and check how much you will get. So it will be around 97656.25. So then simplify the overall value. So you will get around 0.078125. So this is the numerator value and that too only m dash y dx by EA. And again plus L alpha t will be there. So we will check that one also later. So the numerator part up to here, this will be this value, and then go for the next value, that is, so we know the remaining values also, that is integration of y square dx in the denominator part, integration of y square dx by EA, and again we will substitute the remaining values later. So check that one. What is integration of y square dx by EA? So we know y value will be equal to, so here also you can take the same condition, 2 times of 0 to 25. Why I am taking this one will be based on the property. So 0 to L f of x dx will be equal to 2 times of 0 to L by 2 f of x dx. So what is y? 4r by L square x into L minus x, that is y value. And again y square means you can take down all the values in terms of square. So substitute the values, apply square here. 16 r square by L power 4 x square into L minus x whole square dx. And again substitute the value, 2 into 0 to 25, 16 into, where r is the rise, that is 5 square, by L is the 50, that is power 4, into x square 50 minus x whole square dx. So simplify by your own and check later what is the value you will get. You will see that one also later. And again 2 into integral of 0 to 25, 16 into 5 square by 50 to the power of 4 into x square a minus b whole square formula, 50 square plus x square minus 2 into 50 100 x dx. And again simplify, take down the constant terms outside, and again simplify directly that one, and again multiply with the term 50 square x square plus x power 4 minus 100 x cube dx. Okay, so write down this value, how much you will get. This 2 into 16 into 5 square, 2 into 16 into 5 square by 50 power 4. So that one will be 1.28 into 10 to the power of minus 4. Again 50 square into, apply integration, that is x square means x cube by 3 plus x power 4 means x power 5 by 5 minus 100 into x cube means x power 4 by 4, that is 0 to 25. And again substitute upper limit minus lower limit, so the value will be 1.28 into 10 to the power of minus 4, 50 square by 3, x cube is 25 whole cube plus 1 by 5, x power 5 is 25 to the power of 5 minus 100 by 4, x is upper limit, that is 25 to the power of 5. So lower limit will be 0. So substitute all the values, you will check what are the values here. So here the values will be 1.25 to 10 to the power of minus 4. So if you simplify these values by using your calculators, you will get around 103,208.33. Please check the value once in our calculators. So the values will be approximately this much. And again simplify this one and check how much you will get. So this one will be around 666.666. But here in the starting we are also consider this one EA divided by EA. So finally I am taking the value EA directly here also. Otherwise you can keep each and everywhere common. So here dx by A means take down here common the starting from the starting itself, or else you can simplify along EA value here also. So that is 666.66 by EI. So what is the E and I value? So we know E value will be 200 into 10 to the power of 6, and I value will be equal to 5 into 10 to the power of minus 3. So if you simplify again this one, how much you will get? You will get around 6.66 into 10 to the power of minus 4. So this is the denominator part, that is y square dx by EI. So see here what is the horizontal thrust formula. So starting only we wrote that one. So here m square m dash y dx by EI value already obtained. Integral of y square dx by EI value already obtained. And the remaining values we have to substitute, means you will get the horizontal thrust for rib shortening and also neglecting for rib shortening. So first to go for the rib shortening one, first condition. So here I am taking considering rib shortening. Okay, so what is the formula for the rib shortening? So horizontal thrust will be equal to integral of m dash y dx by EI plus L alpha t by integral of y square dx by EI plus k plus L by EAM. So all the values will be there. Just substitute the values one by one and you will see the value. So we simplified already. M dash y dx by I will be equal to, see here, 0.078125, and y square dx by a will be equal to 6.66 into 10 to the power of minus 4. Okay, so take down the values here, that is 0.078125 plus, and in the denominator parts also integral of y square dx by ei will be equal to 6.66 into 10 to the power of minus 4. So we know what is the value of the L. L will be 50 meters and alpha will be equal to, so what is the alpha value given in the question? So that is 1 will be equal to 12 into 10 to the power of minus 6 per degree centigrade. So take down that value, 12 into 10 to the power of minus 6 per degree centigrade into what is the temperature value, that is also 20 degrees centigrade. Okay, substitute all the values and then in the denominator k value will be equal to given, that is 0.0000. So what is the k value? Check once, 0.3001 plus again L value will be equal to 50 by E value will be 200 into 10 to the power of 6 and A value will be equal to how much it will be, 10000 into 10 to the power of minus 6. So see here, A value will be equal to just here 4 zeros and minus 4 value will be cancelled, means that one will be 10 to the power of minus 2 meter square. So that is 10 to the power of minus 2 meter square. So if you simplify all the values, so directly how much it will be obtained? So it will be around 113.842 kilonewton. Just I am substituting the values whatever given in the question. So you please remember the formula and then first simplify these two, numerator and denominator, and then substitute the values directly. And the next part is what they are asking, neglecting rib shortening. Rib shortening. So in the same formula, if they are asking about the neglecting rib shortening, means what we have to do means we have to remove entire this part and also entire this part in the calculations. So the formula will be restricted up to plus k only. So and simplify all the values I will write here. So just to simplify once, 0.078125 plus 50 into 20 into 10 to the power of minus 6 into 20 degrees centigrade by 6.66 into 10 to the power of minus 4 plus 0.0001. So don't take in this value because we are neglecting the rib shortening. So the final value will be around 117.554, 117.554 in kilonewton. So this is the horizontal thrust developed when neglecting the rib shortening, and this is the horizontal thrust developed when considering the rib shortening. So this is the way to solve the problem. Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.